Warm good morning to all the participants of this workshop. I am starting the guest lectures on this industrial robots for future factories. So this the topic is Make in India. Well, Make in India is the keyword formulated by our beloved Prime Minister to make India self-sustained, not depending on other countries for any progress. So this Make in India plays a very vital role in making India self-sufficient. The contents of my top topics are like this: civilization, how this industry started, what is industrial revolution one, revolution two, revolution three, how we come to industrial revolution four, global competitive index, which is a measure where we stand in this, and GDP, marketing hub, manufacturing hub, Make in India. What are the issues involved in Make in India? What are the sectors that we have to consider in this one? And there are the sectors are automobile, food processing, mining, construction, aviation, biotechnology, leather, IT and BPM, oil and gas, pharmaceuticals, electrical machinery, defense manufacturing. We will try to see a few of them if whatever time permits in this. Well, when you see the evolution of the civilization, necessity is the mother of invention. And earlier it was the necessity is the mother of invention. And when they have been meandering in and around, the what is needed for mankind is shelter, food, and some clothing. So initially it was development of skills for farming, weaving, and cattle rearing. That's what the major thing. And if you see the civilization, they will be moving around the globe wherever they could find grassland for their cattle, things like that. Then we have little development, which change in some sort of business started, it's exchange of goods, sharing of knowledge and work. These are the things happened. Then we have the next layer in which for exchange of goods, they had tried to have some instead of from bartering system, the currency came into picture, buying and selling, and try to give some wages for the work rather than the kind. Instead of kind, you start giving the currency for the workforce. Then we have improved the production with some machines were invented. When along with the machines, tools were invented, and crafting was the main focus of this area. So as we progress, then see, when you have some competition, you have to have some selling point. That is where this aesthetics came in and marketing jargons came in. So when you produce more than what is needed for you, then you have to go for exports. So when you go for export, you cannot avoid import also, because you need raw materials, because your production capacity is much more than the raw material available with you. So you need to go for some advertising, and also you have to think of overcoming the competition. So the industry, let us see how it's evolved. Industry 1 is the period of 1760 to 1850. You can say that is the time in England, manufacturing started, manufacturing of iron. Some steam engine, hydro energy was the power from water vapor. That's what the steam engine is. This is the initial starting of industrialization from the handicraft work that has been in vogue till then. Then we have the industry 2. Industry 2 is basically the improvement on industry 1 with mass production and electromagnetism. By this time, electricity was coming into use in a huge scale, and instead of steam power, they started using machines powered by electricity started using. And this is going, a little bit of automation also come into picture during this industry 2. Then we have the industry 3. In industry 3, you know that communication started improving tremendously during this industry 3, and the digital revolution started, and flexible automation was the keyword during this area. So when you talk about this communication or digital revolution, I can share my experience with this computers what we had at IIT. So during my MTech time, that is 81, 83, we had this mainframe computer, so-called IBM computer. The computer occupies a huge room, and for which we have to feed our program through punch cards. We have to stand in queue, book a punching machine, and from the punching machine, we have to punch the cards in that time and feed it to the machine, and we have to wait for the next day to see whether our program is all right. If our program is all right, it would have been compiled and result would have come. Otherwise, the error statement will come. We have to locate those cards, change those things, and then do it. And when I joined for my PhD, during the middle of the PhD, around I think 86 or 87, we had this so-called IPL computer. So there, the greatest improvement there is we need not to go for the punched cards. We have to use we can use the terminal to feed in our program. So this terminal, that display unit, is a line editor. At the center place, there is a line will come. Only that line you can edit. So that was a tremendous improvement for us to feed our programs, to do our research during using computers. But in 88, explosion takes place at IIT Madras in communication through the introduction of Siemens computer with around 110 terminals. So leisurely you can go in and take a terminal, print your, compose your program and load it and get your outputs. That was a tremendous increase. And mind you, the power of those Siemens computer itself is on par or less than the so-called workstations what we are using. That was the improvement that has been coming up during this third revolution. Basically, the communication and the digital revolution has taken place during the industry 3. Then we have this industry 4. Industry 4 is basically your human-robot interaction and augmented reality and virtual reality. And basically, it is driven by the 3D printing. You can see that even the big buildings are being 3D printed, and Internet of Things, which, Internet of Things is the thing which clubs all the branches of engineering, all the branches of activities together, and big data analytics. So sometimes this big data is a nuisance for those who are using Facebook or this type of things, because that's what is bringing up a lot of advertisements onto your page. So they try to analyze your mind by what are the things you are seeing in it. It has gone to the level, that's the artificial intelligence that is being driven into big data. So role of mechanical engineers is in this robotics and using the robotics for industry 4. If you see the first industrial revolution, power from steam and water, turbines were used at that time, and then some tools were used, hand tools, and metalworking was there, and mechanization. This is basically originated from Britain, and for them, they wanted to capture the world by their cotton-based clothing and all those things. and which because their cotton production is less, they started colonizing throughout the world. Spinning was was the main invention that which may make yarn from cotton much easier. So their main aim is to improve the production with mechanization and transportation, because when you produce so much of things, you need transportation to take things around, and mainly the naval transport, because across the ocean that you have to transport your things. That's what developed. Of course, power is generated from water and steam. In Industrial Revolution 2, we have this communication. Revolution 2 is basically in the communication area. First, we have the telegram for slow communication from one place to another. Then you have your telephones, which fast communication, and then electricity. See, in Industrial Revolution 2 was driven mainly by electricity, because the electricity power by electricity can be easily transportable from one place to another, and it is easy to handle, though there are a lot of hazards involved with it. And then your automobile. Automobile was a boom during this Industrial Revolution 2. Plenty of automobile industries were there. And when you come automobile industries, accessories, spare parts is a very big thing along with that. Then you have, when you automobile industry are once again associated with mass production, the so-called transfer lines. Nowadays, you may not hear about that much. Transfer lines were invented for this mass production, wherein it's a fixed automation. That's what the transfer line is. Then you have your new materials and alloys. See, when you conventional materials are not meeting your requirement, and you need higher hardness, higher temperature bearing capacity, and ease of manufacturing. These things they brought in the new materials and alloys for industrial production. The countries which are forefront in the second industrial revolution is Britain, US, Europe, and Japan. And the medium is once again iron and steel making. With steel, what we mean is a lot of alloys that came into picture in this area. The major, as I told you, the breakthrough invention during this is electricity and its transport. The aim is mass production, because that's what driving the automobile industry is, and transportation is railways, road transport, and marine. So the third revolution, which is for various, if you see the period of this revolutions, first revolution was some time, and second revolution was a very long duration. Third revolution was a very short time. It's around 30 to 40 years. So in this third revolution only, we had this CNC. This is taking into the computers onto the machines. There's computer numerical control. Machines came into picture, which made the transfer line, that is fixed automation, into flexible automation. You had your digital electronics. You could have seen that a lot of boom in the digital electronics during this period, which is once again revolutionized your CNC machines and your automation. And electric vehicles started introducing during this period. Even still in the progressing stage in electric vehicles, we have not yet reached the final part of this electric vehicles. Though there here and there good quality vehicles are coming up, still we have to go a long way in having the practical electrical vehicles, wherein the development of batteries coming in as a big hurdle in this area. Then we have internet. Internet was introduced somewhere in 1990. After that, the globe has become a very small village. And then this environmental concerns made us to think for alternate source of energy, which is, we call them as unconventional power sources. And vehicles are also, because of the oil crisis, they wanted to go for other source of energy. Of course, flexible automation, as with the integration of CNC machines and electronics coming into it, flexible automation has come into picture. which made it possible in the same line you can manufacture different types of machines, automobiles, or whatever it is, with very little changes in the configuration. The forefront in this third revolution is Belgium, Germany, France, US, and Japan. And generally, once again, it is only the manufacturing it was driving the third industrial revolution. The invention in this area, major invention, is the development in the electronics. The main aim in this during this third revolution is automated production, trying to reduce the human interface within this. And of course, during this period, the aviation took up very large space in transportation. When it comes to the fourth revolution, fourth industrial revolution, that's what we are in now from 2010 onwards. The countries involved in this are Canada, Japan, Germany, Australia, Switzerland, and Austria. And you can see that Britain is phased out from this third and fourth revolution. And then the aim of this fourth revolution is mass production with flexibility. Or I would say it's production for requirement. Whatever required at that time, you have to produce things. That's what the aim of this fourth revolution is. Then the medium is skilled work with unskilled labor. The type of via media what you introduce will make the unskilled laborers to do the skilled work. That is, the skill is taken away from the human beings, from the workers, and given to the machines through the robots and other things. The main invention is IoT, as I told you, which is integrating all branches of engineering and augmented reality and collaborative robotics, 3D printing, and big data, data analytics. These are the main inventions which is driving this fourth industrial revolution. We want to be in the fourth industry 4. We have to be good in all these areas. And mind you, these are you cannot say this is for a particular branch. Say it is electronics engineering. They say it is computer science. Without computer literacy and adequate knowledge in computers, you cannot be even a mechanical engineer, or you cannot be even a civil engineer, because 3D printing is what is revolutionizing the building construction nowadays. And you would have seen quite a few of them in the YouTubes, how this 3D printing is made use of for bringing up the buildings. So in Industry 4, we start from big data. Lot of data has to be crunched, and from that, what is needed for you has to be culled out very easily through this data crunching techniques. That's what the big data is. Then mobile technology, you can see that classrooms you would have seen, when you have a AC and remote control AC, some of the students will be fiddling with the AC through their mobile phones. So these mobiles now basically have made the revolutions for Industry 4 revolutions a great success, and even quite a few of you might be attending this program itself through your mobiles. And another one is because of the advent of this communication technology, machine-to-machine communication has become very easy, and that is what driving the IoT itself. Then wireless system to connect the systems and the products. Then optimization of real-time process from intelligent systems. So optimization has come to in a large scale. Now, optimization has gone to the level of standardizing the food what you eat. And some of these food giants, they were telling in a few years time we will decide what you should eat, not what you will eat. That they will be deciding. That's because of this optimization and how the people are food habits are there, all those things. are also data crunched and some to this. The simulation is what is driving it. Then you have this cyber security, because of course, when you have so much of data being utilized from cloud and from different systems, see a lot of cyber crimes are coming up. Obviously, cyber security is another field that has been developing vastly during this industry 4. Then you have augmented reality, which will let you know what is happening in the heart of any action that's taking place. And cloud computing, and no longer you need to have the terabytes of data in your computer. You can store things in cloud, which can be accessed from anywhere in the world. Of course, the 3D printing, as I told you, it is coming up in a large scale in mechanical engineering, in civil engineering, in even in the electronic industry. 3D printing is coming up. IoT, as I told you, it is linking all the branches of engineering into one, and system integration is what is part of this IoT. Through IoT and system integration, you can do anything what you want. You need not be an expert in any particular field. The only thing is you should know who is expert and who can deliver things for you, and you can integrate things on your own. And advanced robotics from pick and place unit and for assembly unit, it has developed into robots which can do what any human being can do, and also the memory capability of not only memory analytical capability has been built into the robots. They can decide what to do, which makes them to drive vehicles on the road. These are the things what we are having in your industry 4. So global competitive index, this is what tells you where a country stands in competition. By far, United States of America comes first with 85.6 as a competitive index. Then you have Singapore, 83.5. And Singapore being a small country, not even a country, it's a city, big city. Because of this IoT and the system integration, they could have this much of global competitive index. Then Germany, of course, they have 82.587 as a index. Switzerland, once again a small country, 83.5. Japan, they are always in the forefront in this 82.5. And Netherlands, I don't get the data here. $82.4, and then you have Hong Kong. Hong Kong is 82.3, and Britain is 82. You're wondering where India stands. You have Sweden. Sweden is also doing very well, 81.7, and Denmark 80.6. But you're wondering where India stands. India is having only 61.36 and in 43rd position. So we have a long way to go in your global competitive index. What are the things which facilitates your global competitive index? First is markets. You should be able to access the market effectively in the global market that you have to access. Then human capital. Human capital, labor productivity. It's not the number of human you have, it's the productivity is what's main important aspect over here. And enabling environment. And whenever you have mass production taking place, and if the environment is getting damaged, you are spoiling the future. So environment enabling is also a very important part in this GCI. And you might be wondering that this forging industry, Bharat Forge, now it has gained a lot of market, not because of their, not only because of their capability, but because the countries which were doing it, the European countries which were doing it, they preferred to offload it because it is noise polluting industry. So this type of thing we should be careful about. We can take up, but what is the environmental impact of those products that we have to study, and then only we have to take it up. The another one is the port modification, modernization. So you need to have a innovation ecosystem available in your country for you to progress, to get a GCI. So when innovative ecosystem is there, wages also will go high for the laborers. So US number one, Singapore number two, Japan three, Germany. These are all for GDP. If you go by the GDP, gross domestic product, first is US, second one is China, third one is Japan, fourth Germany, and fifth is India. But you see a huge difference between first and second, as well as second and third. And compare India, it is only seven times less than China, and it's only 1/10 of US. We have a long way to go in our GDP. The one interesting factor here is the growth rate. So US, Japan, and Germany, their growth rate are 2%, little more than 2%, whereas ours is at 6.68%, and only China is slightly more than us. So that means we can catch up with the other countries. For example, we can catch up Germany very fast. We can catch up Japan also very fast. And per capita, if you see, per capita income, if you see, India is the least. That means labor force is very, very cheap in India. If you take the share of whole GDP, ours is only 3.28, US is having 24%, and China is having 15%. So this here also we have a very long way to go. And if you take the share of manufacturing, we are doing relatively well. And if you see the US is not taking up any manufacturing load, they have been offloading into countries like China, Vietnam, India, this type of things. And that's why China is having 26%, Japan is 21%. And our manufacturing sector is improving, and we can catch up with other countries fast. So if you take the gross domestic product, it is tells you about the trade deficit. If you have imports more than exports, that means you are net importer. So that's why this Make in India is becoming a buzzword nowadays. World Integrated Trade Solution Report says that growth of the countries which is gone down during 2009 is picked up and slowly stabilizing over there. The world growth is also following the same pattern, and the GDP growth is uniformly going up. Okay. Then we have this marketing hub. Marketing hub, this one is the economy. And now if you think about India, we are the 5th largest economy. Then we have consumers. Our population is number 2 in the world. And not only that, 50% of more of them are youth. Youth are the real consumers for this. Area-wise also, our 7th largest country. So that also is a good point. Living standards. Living standards, we have a huge middle class. 55% middle class is there. So middle class is what the consumers, major consumers. So that also makes us the good marketing hub. And transportation, we have the largest coastal region available with us. And technology adoption, because of the standard of learning in India, we can adapt to any technology very easily. And cultural diversity, we have 29 states, 16 unique cultures, 22 languages majorly spoken. So cultural diversity is also there within our country. These are the things which makes us a very good marketing hub. Marketing for world as well as internal marketing is potential is tremendous in India. When you talk about the manufacturing hub, India as a manufacturing hub, what are the points to be considered? Global infrastructure. And what we need is uninterrupted transportation of the exports and imports. And the government is to facilitate this infrastructure. Number two is ease of doing business. This is the buzzword among the politicians, among the government people nowadays. Ease of doing business is what is to be improved for us to be world leaders in near future. That calls for reduced paperwork and easy approvals. And number three is what low cost. As we have seen that our labor cost is very low compared to even China. So manufacturing expenses will be reduced because of that, which makes it feasible for India to become a manufacturing hub. And the next point is technological upgradation. Because of the nature of the India being one of the leading countries with English as a medium of instruction, we can easily adapt to this technology upgradation. Next is skilled labor. This is where our government is focusing now. Skilled labor is limited right now, and we are Skill India programs. These type of things are mainly made to make skilled labor force available in India. Then last one is some more supporting MSME. And for our country, MSME is the backbone. Micro, small, and medium enterprises are the backbones of manufacturing hub. So they have to be strengthened, and there are schemes evolved by the government even during this pandemic period to support this MSME. The support for MSME is really a welcome feature to sustain manufacturability in India. And a skilled labor force that we are supporting MSME. These two are, as I told you, are the main important factors. The government is doing all possible means to improve these two areas. What are the attractive factors for manufacturing in India? Make in India. Number one, large consumption phase and high technology adaptation rate. See, as I told you, we have 130 crores population, of which 55% is youngsters. That means consumption will be large, and our educational level is fairly good, and so the technology adaptation will be easier. Next is logistics and human time potential. And in the logistics is also good over here. That has to be improved, but still it is not up to the level of the developed countries. That has to be improved. The port modernization, all those things coming because of this, and the railway lines are being revamped. And we have a very large developing economy which drives manufacturing in India as Make in India as a good prospect. And you have massive investment in physical and digital infrastructure and focus on sustainability and environmental conversation. So, the process of extensively concentrating on Make in India, we have to look into the sustainability as well as the environmental aspect also, because this world belongs to our future generation. It does not belong to you. So you cannot destroy the ecosystem here at the cost, because that belongs to your children. And tax reforms and young workforce, the plenty of tax reforms have come which make it an attractive destination for foreign direct investment. FDI is coming, pouring into India at a very large scale. That's because of this tax reforms and workforce availability. And of course, our government is the business friendly, and ease of doing business is very much enabled in India. All these factors will help in making India a success story. And finally, you have abundant natural resources that's also available with us, and that is being tapped nowadays. Let us see what are the targets set and what are the achievements in Make in India. And increase in GDP from 16 to 25% by 2022. This is one of the major, but we could get only 16 to 20% by 2021. So we are lagging in this. We have to put more good effort within 1 year. We have to make from 20 to 25%. We have to go, which is really a Herculean task that we have to put a full effort on that. Create job opportunity to 100 millions, but what we achieved is only 25 millions. That is Skill India. The concepts are there, and the contribution from industries has to be improved, and contribution from institutions has to pitch in Skill India programs. Then only this job opportunity, because job opportunity will come only if you have the skilled people available to do the work. That we have to do it. And right now we have only this software people available with us. That has to change. Even core engineering students taking up only software jobs, that has to stop. They have to be skilled enough to take up manufacturing jobs. Attract foreign investment. That we have been doing it very steadily, and that still we can improve. We are only the 9th position. We can still go further in that. Improve exports. That is taking place tremendously. 60% increase in exports achieved. Encourage domestic production. There are production link incentive schemes worth 51,000 crores given under Atmanirbhar 3, and encourage the domestic production encouragement is taking place in a very large scale in the present regime of the government. So this is where we are lacking very much GDP and job opportunities. These 2 points that we have to address it. What are the sectors? Automobile, food processing, mining, construction, aviation, biotechnology, leather. See, automobile sector, we have been growing very fast, but recently some setback is there because Ford has decided to close down the company here. Definitely there's a setback. We have to address that. And food processing, it has been taking place only now. This is one area we can make a tremendous improvement in Make in India. Mining is picking up only now. Construction activities are there. It is the 2nd largest industry right now. And aviation, it picked up tremendously, and some drop is there, and that has to be once again addressed and come up. Biotechnology, though we have good pharmacy industry, biotechnology is not up to the level of other countries. We have a long way to catch up in that. Leather, of course, we are doing very well. IT and BPM is our strong area, but we have to be the developers rather than the users of that. Oil and gas, and with limited resources, we are trying to do it very well. Electrical machinery, yes, it is not picking up that much. Pharmaceuticals, this is really our strength, and we have to improve on that. Defense manufacturing, and only now it is picking up. The identifying defense corridors. from Trichy to Coimbatore belt and things like that. That is to really pick up. That should pick up from now onwards. Automobile components. This is the one industry where we are doing really well. And automobile components, many of you may not aware, for all the leading automotive companies, our MSMEs are supplying the components. And chemical industry is something still we have to go a long way to go. And textile and garments, we were ruling the roost once. Now Vietnam and Bangladesh are the biggest challenges for us that we have to address and come out of it. And thermal power is the thermal power. We are still in the stages of importing the technology only. We have to revamp on that. Tourism and hospitality, among all the countries, we have the best possible destination for tourism, and we have to still tap the potential to the fullest extent. We have not yet done it. We have to do a lot of work on that. And railways, of course, they have been doing very well now. With a lot of changes have been made in railway networks and railway operations, and it's really picking up. And wellness, India is the father of wellness, or the mother of wellness. Any wellness program, yoga or anything, and it's only the Indians who have been the forerunners in it. And we have to try to keep that edge over other countries. And space, this is where we are silently doing extremely well. And the cost of putting a satellite in the orbit by ISRO is the least in the world. That's why there are so many countries, including US, taking the help of ISRO to put their satellites in space. And roads and highways, think about 10 years back and what is now. You see, so much of improvements we have made in roads and highways. Though that there are a lot of toll booths are there, it's inevitable. And our roads and highways are of very high standard. And renewable energy, we are slowly catching up at the face of growth. I don't think it is up to the mark. We have to do a lot of things in this renewable energy sector because we have tremendous potential of solar energy and wind energy that has to be fully tapped. So that the dependence on oil and gas and coal has to be reduced to the maximum extent. And media and entertainment, well, we are doing really well in this sector. So what are the issues regarding Make in India? So we have seen the sectors. What are the issues? Investment from shell companies. So see, our Indian entrepreneurs, they are masters in beating the systems. So that's why investment shell companies make the company itself is a shell company. Low productivity. Our productivity compared to Chinese companies or developed countries is really less. That we have to improve. Small industrial units, it is good, but for not for all sectors. And this they have to be the integration of the small industrial units so that they can do very well. And we have the labor laws a bit complicated. It's not the hire and fire, which is not good also, but that has to be eased out. Insufficient rules and regulations. There are a lot of loopholes in our rules and regulations, which makes make in India a bit difficult. And red tapeism is also still there that has to be addressed. And transportation, though we have tremendous improvement made in this transportation sector, still there are some lacuna in this transportation. And infrastructure, though we have been improving, but still it's not sufficient to be globally competitive in making make India a success. So of this manufacturing strategic plan, technical depth in manufacturing. Okay, let us see some of the sectors wherein we can concentrate. First is the automobile components. Automotive market to reach US dollars 300 billion. And after market segment, US dollars 32 billion by 2026 is what the target set for this. To make contribution to automobile spare parts in GDP from 12% from 12% by 2026 is targeted. To create 65 million jobs by 2026 is the target set for this. To promote the hybrid and electric mobility and 6 to 7 million electric hybrid vehicles by 2026 has to come up. And I think this is a achievable target with the Tata Motors stepping in with their EVs. To receive US dollar 2.15 billion for building a roadmap for electric and hybrid vehicles. It is possible to achieve. What is achieved with increase in India after market segment raised by 9.6%, that is from US dollars 9.2 billion in 17-18 to 10.1 billion in 18-19. Mrs. Stanley Black & Decker had 3 manufacturing plants in India and established with US dollars 15 billion revenue. FDI equity inflow is US dollars 25,843 billion from 2021 to 2020 to 21, 4.8% of total FDI. Fund record is in US dollars 1.44 billion over 3 years from 1920 to 21-22. The automobile component in India contributes 2.3% to India's GDP. About 1.5 million people are directly and 1.5 million people indirectly are employed in this industry. The automobile component industry in India will stand a long way along the top 3 of the world in engineering, manufacturing, export vehicles and components. Because some of the automobile components India only is making. What is scope for development? To enable infrastructure like automotive training centers, special auto parks, and virtual special economic zones for auto components has to be brought up. To develop the supporting factors for investment of large pool of skilled workforce and strong educational system. Everything boils down to skilled workforce. What are the schemes available? Automotive Mission Plan 2016 to 2026, 10-year mission plan. AMP 20 Automotive Mission Plan 16 to 26 seeks to outline the trajectory of the advancement of the automobile component industry ecosystem in India. National Electric Mobility Mission Plan 2020. It aims to bring the transformational paradigm shift in the automotive and the transportation industry by promoting hybrid and electrical mobility in India. It predicts a vehicle population of about 6 to 7 million electric hybrid vehicles in India by 2020. FAM scheme phase 2. The scheme is proposed to be implemented from April 19 to April 22 for faster adoption of electric mobility and development of its manufacturing ecosystem in the country. Financial support, R&D incentives for industry and private sponsored research. A weighted tax deduction is given under Section 35 of the Income Tax Act. State incentives, Andhra Pradesh, financial assistance limited to 70% of cost for obtaining patent registration and 50% of all charges. Gujarat, auto component manufacturers can either avail general incentives under Gujarat Industrial Policy 2015 or under the scheme for mega innovative projects. Jharkhand, the policy encourages the establishment of tires for auto component manufacturers in the state. 100% electricity duty exemption shall be provided for 10 years from the date of production. lot of incentives, financial supports are coming up. Foreign investments, 2F Germany, ZF Germany, Asian Seiki Company, Bosch, Continental Engineers, Delphi and Denso, FAG, Magnetic Mirroring, Tally, TRW, Valio, Stafford, Honda. So a lot of foreign investors are coming to India, and that has to be nurtured, and it has to be still further broad-based. Next is the automobile industry. What are the targets? Let us see. India is projected to be world's third largest automotive market in terms of volume by 2026. As per AMP 2026, the automobile industry has a target to triple the revenue US dollars 300 billion and increase export sevenfold to US dollars 80 billion. By 2026, as per Automotive Mission Plan 2016-26, the automobile industry has the potential to contribute about 12% of total GDP and create 65 million jobs. What is achieved? India gets Asia's longest and world's fifth longest high-speed track for automobiles. BHL has spent around 30 crore on R&D expenditure and filled 34 patents. They are very much into this EVs. India is the largest manufacturer of TW and 3W and fourth largest manufacturer of two-wheeler and three-wheeler, and the fourth largest manufacturer of passenger cars in the world. Scope for development, the need for quick rollout of flex fuel vehicles capable of running on 100% ethanol and gasoline into the Indian auto market within a year's time. With successful available technologies in Brazil and US, we can adopt those technologies here. What are the schemes available? FEM India scheme 2-phase. Scheme aims to create demand by way of supporting 7,000 e-buses, 5 lakh e-3-wheelers, 55,000 e-4-wheelers, passenger cars, and 10 lakh e-2-wheelers. Automotive Mission Plan 1626. Automobile industry is projected to be the third largest in the world, contributing 12% of the GDP. Draft National Automotive Policy 2018. Department of Heavy Industries formulated a draft national automotive plan for the holistic development of the automobile industry in India. National Automotive Testing and R&D Infrastructure Project aims at converting India's unparalleled strengths in IT and electronics with the automotive engineering sectors. Financial support, R&D incentives, manufacturing with Innos R&D centers are given a lot of incentives, state incentives. Andhra Pradesh, the government of Andhra Pradesh is committed to providing land at concessional rates along with 24-hour non-stop power supply. Gujarat can either avail general incentive under the Gujarat Industrial Policy Scheme or incentive under mega innovative projects. Jharkhand also once again the same thing. Foreign investments, Daimler, Fiat, General Motors, Honda, Hyundai. Almost all the major players are here in foreign investors. Targets for defense manufacturing. What are the targets? The defense policies aim is to achieve economic of scale, including development of capabilities for the exports, government policy which promotes self-reliance, indigenization, and technology upgradation, to increase the focus on homeland security and growing attractiveness as a defense sourcing hub. What are the achievements? Value of defense export in 2021 is 5,911 crores. Indigenous defense product unveiled Akash surface to air missile system, Dhanush artillery gun system, and light LCAs also come up. The maiden flight of indigenously developed automatic flight control system integrated to LCH was conducted successfully by Hindustan Aeronautics Limited. The DRDO achieved a major milestone with the launch of medium-range surface-to-air missile. The missile completely destroyed a high-speed unmanned aerial target, which was mimicking an aircraft with a direct hit. What are the scope for development? Supply chain and sourcing opportunity, modernization of the armed forces, infrastructure development, research and R&D in this area. And what are the schemes available? Procurement policy. Defense procurement is governed by the defense procurement procedure. The latest division of DPP was released in 16. It focuses on institutionalizing, streamlining, and simplifying defense procurement procedure to give a boost to the Make in India initiative. Offset policy. The key objective of the defense offset policy are to leverage capital acquisitions to develop the domestic defense industry. Defense testing facility, scheme to boost domestic defense and aerospace manufacturing, and 4,400 crore outlay to create state-of-the-art testing infrastructure in partnership with industry. And project consultant officer can be contacted for clarification. Financial support, allocation made to armed forces, covering both revenue and capital heads are 3 lakh crore rupees. Basically, the capital expenditure among, they say, 1 lakh crore. Union budget for 21-22 showed highest ever increase in capital outlay of 1,35,000 crore in the last 15 years. For the year 21-22, the allocation for domestic procurement has been enhanced compared to the previous year, and this year it is about 64% of the allotted amount for military modernization. Foreign investments, BAE Systems, Pilatus, Lockheed, Raytheon Technologies, Rafael, the Dassault. So what are the targets of your aviation industry? Aviation industry is growing steadily till this pandemic struck. Now it's yet to take off. Industries, the US dollar 30 billion contributions to India's GDP. The domestic aviation market is projected to rank third globally by 2024. India is the fastest growing aviation market, and as per IATA, the country is expected to cater to 520 million passengers by 2037. India has the potential to be a global drone hub by 2030. So we have to go a long way in developing the drones. AAI has embarked upon development and expansion of airports in the country at a cost of 20,000 crore in the next 4 to 5 years in order to meet the growing passenger demand in the country. So what is achieved? Open sky policy for foreign cargo carriers promulgated wide AAC 18-1992 has been reviewed by the government, and some changes have been made with a view to ensuring fair and equal opportunity in the air cargo capacity offered by India's registered airlines and airlines registered elsewhere. Next one is, during the last 5-year plan, an amount of approximately 70,000 crore has been spent by the government, Airport Authority of India, in renovating and building airports. Now you can see a lot of good airports coming up throughout the country. And scope for further development. For the development of aviation industry in the northeast states, Airport Authority of India plans to develop Guwahati as an inter-regional hub. It also plans to develop Agartala, Imphal, Dibrugarh as intra-regional hubs. Next, India airports are emulating the special economic zone Aerotropolis model to enhance revenue. The model focuses on revenue from retail, advertising, vehicle parking, security equipment, and services. What are the schemes available? Regional connectivity scheme, Then the first flight was flagged off at the newly constructed Hisar Airport in Haryana from Chhattisgarh. 34 routes were operationalized, which were awarded under 3 rounds, that is unserved and four unserved: Gwalior, um, Bengaluru, Durgapur, and Chillang, and airports connecting 10 served airports, that is Raipur, Bhubaneswar, Kolkata, Bangalore, Mumbai, Hyderabad, Goa, Kochi, Rajahmundry, and Vizag. So this small flights from unserved to served sectors will definitely boost the domestic air transport. What is the financial support? Review of airstrips, airports as no-fill airports at an indicative cost of 7.1 million to 14.3 million. Demand-driven selection of airports, airstrips for revival of consultation with state governments and airlines. The viability gap funding to airline operators, reduce the service tax and tickets, and reduce the excise duty on ATF picked up at RCS airports. For foreign investors, Airbus, Boeing, Rolls-Royce, AirAsia, Frankfurt Airport, Honeywell, GE, Malaysia Airports, Alcoa, Singapore Airlines, Etihad, Fairfax. So some of the areas where we have to concentrate, what we are doing that we have seen so far. This is the final place where we are in advanced robotics, big data, mobile technology, machine-to-machine communication, radio frequency amplification and technology, simulation, cyber security, augmented reality, cloud computing, 3D printing, Internet of Things, system integration, robotics. So yes, Industry 4 robotics plays a vital role in future factories. So this 5 days of program will help you in understanding role of advanced robotics in future factories. Thank you very much for your patient hearing for almost 1 hour. Thank you.